Very good. Good afternoon. Where did we start last week here, right? Multiple linear regression. Betul tak?
Betul.
Okay. So kita continue kat sini this week. So before that, okay, make sure you mark your attendance through Putra Blast. Make sure you mark your attendance. Okay, so we continue with multiple linear regression. So last week we already done with simple linear regression. Okay, in which the purpose of regression is to make prediction, okay, to determine the flow of relationship or direction of the relationship, to determine the magnitude as well as to make prediction regarding a certain phenomena. Okay, so this one, multiple linear regression. So multiple linear regression is the extension, is an extension of simple linear regression. Meanwhile, simple linear regression is an extension of Pearson product moment correlation. Okay, dia saling berkait. Okay, so the purpose again to use the regression or multiple linear regression is to determine the relationship between IVs and DV, which is we have more than one IV in our model. Okay, so the second objective to determine the effect or influence of IVs towards the DV. Okay, lastly, we want to make prediction of the DV based on IVs, based on set of IVs. Okay, so the requirement to run the multiple linear regression is we need to make sure that the scales of measurements for variables for our DV must be interval or ratio. Same goes to our IVs. It must be in interval or ratio only. Okay, it must not be in categorical form, either nominal or ordinal. Okay, for non-metric categorical IV, it must be transformed. This one is a high level so in which I'm not going to cover this one. It is possible if you have the categorical IV, it's still possible, but you need to change or transform your category into the dummy variable, which is we will use 0 and 1. Okay, as the code. Okay, so the assumption to run the multiple linear regression include, first, we need to make sure that we have ample sample size for generalizability purpose. Okay, make sure you follow a certain a specific type of a specific strategy to determine your sample size so that you can define, okay, the number that you have in your study, the number of sample that you have in your study. Okay, so this one is also you can secure the generalizability of your study from the sample to the population. Okay, and then we settle the issue of multi-collinearity and singularity. Okay, so there is no issue of multi-collinearity. Multi-collinearity meaning that the IVs themselves have a strong relationship. So kalau kita ada hubungan yang kuat antara IV tu sendiri, dia ada hubungan yang kuat, sebenarnya dia akan mengganggu hubungan IV tu dengan DV. Okay, singularity ni meaning that we need to make sure that the variable in our study measure only one thing. Okay, that's why it is connected to our instrument, which is validity. Okay, dia berkait sangat. Okay, then we need to make sure that there is no outliers in our data set. Okay, and then make sure our data meet the assumption of normality, linearity, homoscedasticity, and independence of residuals. Okay, and then the case represents a random sample from the population. So these are the 5 assumptions that we need to follow to run the multiple linear regression. Okay, so in terms of sample size, okay, we should have ample sample size to ensure generalizability. Okay, 15. Okay, this is the general rule given by Steven. Okay, he said that we need 15 respondents per predictors. Tapi this one is too small unless you are conducting an experimental research. Kalau you conduct an experimental research, then you may consider this number. Okay, and sample size larger than 50 plus 8M, where M equals to number of IVs according to Tabanik and Fidel. Okay. So you can also apply this rule. Okay. Okay. Another method that you can use, for example, you can use any statistical software, any software through online. For example, sample size to determine your sample size, or you can use G-Power. The most regular software that been used by postgraduate students are G-Power. Okay. So itu adalah sample size teknik yang you all kena guna. Pilih mana satu mana yang nak dipakai. Okay, next one is the issue of multi-collinearity. Okay, so it is referring to the height relationship among IVs themselves. Okay, and then it exists when IVs are highly correlated. For example, when you test the correlation, you found out that the relationship between IVs themselves are 0.9 and above. So this is the cut-off point, 0.9 and above. Okay, so R equals to 0.7 potentially to be deleted. So for R equals to correlation coefficient equals to 0.9, for sure this is an issue of multi-collinearity. Okay, but if R equals to 0.7, so this case you can consider to delete the case. Sebab 0.7 pun dah considered to be height relationship between variables. Okay. So next one, singularity. So singularity ni referring or occur when one IV is actually a combination of other independent variable. So for example, in your IV, the instrument in your IVs ni, one IV ni consists of items that connected or measuring another thing. So this one ni, it will be connected with your validity. When you develop your instrument, dia akan ada isu, dia akan balik kepada isu instrument singularity ni. Okay, because sometimes the height correlation between IVs and DV ni is due to the two variables ni measuring similar thing in the instrument. Sebab tu dia ada hubungan yang sangat tinggi. Okay, same goes to another IV. Kadang-kadang komponen tu dah diukur dalam IV pertama, tapi dalam IV kedua ada lagi. So that's why when we run the correlation or regression, we found a very high connection between the variables. Okay. Okay, so outliers. Outliers ni, okay, so MLR multiple linear regression is very sensitive to outliers. So very high to very low score. So outliers ni referring to a very high, which is beyond the majority or below the majority, okay, in our data set. Okay, so all IVs and DVs should be free from outliers. Both data for our IVs and DV must be free from outliers, okay, in which we need to determine or delete the outliers ni during our screening process. Oh, mengah. Okay, during screening process ni, meaning that during our EDA process, exploratory data analysis process. Yang kita dah belajar dah sebelum ni, tapi hari tu saya tak sentuh lagi lah part outliers ni. Okay. So outliers for the DV can be identified from the standardized residual plot. Okay, we can determine or we can identify the outliers for the DV from the standardized residual plot. So standardized residual values above 3.3 or less than 3.3 considered to be a potential outlier. So ni 3.3 bukan 0.3. Okay. Okay, the cut-off point is 3.3 plus minus 3.3. Okay, plus 3.3. Okay, next one, normality. So normality ni referring to the residual should be normally distributed about the predicted DV score. So this one similar to what we already learned during our previous lecture. So we follow the requirement or we follow the methods to determine the data normality. Either you want to use a statistical analysis such as Kolmogorov-Smirnov or Shapiro-Wilk to determine the normality, or you can use the figures or diagrams such as box plot, Okay, you can use PP plot, QQ plot. You can use what else? Skewness, kurtosis to determine the normality. Okay, and the next one, linearity. Linearity ni referring to the residual should have a straight line relationship with predicted DV score. So we want to make sure that the relationship between our IVs and DV are linear. Okay, linear relationship. Mestilah dalam bentuk yang straight line relationship. Next one, homoscedasticity. Okay, so homoscedasticity is referring to the variance of the residual about predicted DV scores should be the same for all predicted scores. Okay, so nanti kita akan tengok satu-satu. Okay, so what to expect in multiple linear regression analysis? So you are able to derive the regression or prediction equation. So same goes when we learn what we learned during our SLR. So we need to derive our prediction equation. Okay, we determine the best predictor. Okay, because in MLR it consists of the analysis of more than one IV. So that's why it is possible for us to determine the best predictors. Okay, sebab kita ada variasi. Kalau dalam simple linear regression kita hanya ada satu IV, itulah the best, itulah yang paling the weakest. Okay. Next one, we run the hypothesis testing. Okay, we refer we report the regression model. Okay, the full regression model, either it met the it fit the data or does not fit the data. Okay, in which from the model we will describe or determine the R square and R value. Okay, and then we will see the slope. Okay, the slope. Okay, so this one. Okay, so these are the components of multiple linear regression. The descriptive part we will determine the constant B0, B1, B2, and Bn. So Bn ni bukan barisan nasional So it is referring to the number of number of variables. Okay, determined based on the number of variables available in our data set. Okay, so then based on the value, the B's ni, we can determine our prediction equation. Okay, in which y hat equals to B0 plus B1x1 plus B2x2 plus Bnxn. Okay, and then based on this, the list of based on the prediction equation or based on standardized beta, we will determine the best predictor. Okay, the R and R square as well. Okay, and then for the inferential part, okay, we will we will determine either our regression model fit the data based on Anova Table, and then we will determine the slope. Okay, the slope kecerunan. Okay, yang ni tak apa, ni pandai dah ni, laju dah ni. Okay, ni laju, ni sama. Okay, so interpreting the prediction equation, so based on a given prediction equation, you can indicate the influence of IVs on DV. So this one is the example of simple linear equation. Saya lupa nak tukar. Okay, so for example, how to read this one similar to what when we read the finding from simple linear regression. So if let's say your finding is y hat equals to 1.07 plus 0.75x, so it means that for every 1 unit increase in x, y will increase by 0.75 unit. Same goes to when we read the finding from the multiple linear regression. Okay, so the amount of increase, decrease in y is based on B1. Okay, so next one for experiment for the part this one. Okay, for the testing, hypothesis testing. This one step. Okay, so for hypothesis testing, we follow the similar step, the similar 5 step. First, you state your hash naught and hash A, then extract the significant F value based after we run the analysis, set our alpha, make the decision, and lastly make our conclusion. Okay, first one, to state our research and null hypothesis for multiple linear regression, Okay, this is the statistical form. This is the statistical form, hash naught y equals to b naught plus ei. And our research hypothesis y equals to b naught plus b1 x1 plus b2 x2. The number of b here and x here depending on the number of variables included in your study. If you have 3 IVs, then your b ni will stop at b3 x3. Okay, so this is the statistical form to state our research and null hypothesis. But for practical, we can state our hypothesis as, okay, our overall model hypothesis as hash naught the regression model does not fit the data at alpha 0.05 or 0.01, or the regression model fits the data at alpha 0.05 or 0.01. So again, the regression model ni referring to the overall model. Overall model. We not yet specify which variable contributes to the DV, but we set our we set our hypothesis in general or in overall. Okay, and then before we are able to extract our data, so we need to run the analysis in Ibm Spss. So I give you a few minutes to open your data set. ERS 5951 dataset. Okay, please open the dataset. Dan show data ready?
Yes, Dr. Normi.
Okay, good. Okay, so to run the analysis first, click analyze, click regression, and click linear. Analyze, regression, linear. Okay, analyze, regression, and linear. Okay, next one, in the linear regression box, you locate your DV and IVs accordingly. So for example, I locate PB mean as my dependent variable, and then task and avoidance copying as my independent variable. Okay, I use task and avoidance copying as my independent variable. Okay, that once done, click statistics. Sorry, for the methods we use enter method. Okay, I already explained about the method last week. Okay, next click statistic button. This one, statistic. Okay, under statistic box you choose for regression coefficient, estimates, and confidence interval. You locate 95%. Okay, 95%. Confidence interval 95%, up to you. If you want to set at 99% pun possible. Okay, and then tick for model fit, descriptive, part and partial correlation ni tak payahlah. Part and partial correlation just ignore. And then collinearity diagnostic. Okay. And then case wise diagnostic ni for outliers outside 3 standard deviation. Okay, so as what we learned just now, the cutoff point is 3.3. So we put it as 3. Okay, and then click continue. Okay, next we click plots. Click option plots. Okay, so we locate Z residual under Y and X for X Z predicted. Z residual, Z predicted. Okay, and then standardized residual plots, we choose normal probability plot. Then click continue. Okay, now for save, click save. Okay, under save, you you focus on distances, tick for Mahalanobis and Cooks. Okay, tick for Mahalanobis and Cooks. Click continue. Okay, now for options by default, I thought by this one by default. Okay, but click continue. Okay, and now click OK. This one I already explained last week. Okay, so this is our finding. Do we get similar thing? Do we share similar finding? The first table is descriptive statistics, descriptive table. Do we share similar finding?
Yes, doctor.
Okay, so the first table will indicate the descriptive findings for our data set. So it should be consistent with the earlier analysis that we did. Okay, it shows the mean and standard deviation. Okay, so mean and standard deviation of the variables. Okay, next one. Okay, we will see the correlation table. Okay, it will indicate the Pearson correlation result. Okay, this table also should be consistent with the analysis that we run in Pearson product moment correlation. Sama sahaja. Okay. Then next one, information related to method that we use, which is enter method. Okay, indicates the regression method that we use. Okay, next one, the model summary. Okay, in which the R multiple correlation coefficient R indicates the correlation between the three variables. Okay, in multiple linear regression, we report the R result, but we do not interpret. We just report. Okay. Okay, next one. The R squared value, which is identify the proportion of variance in our DV accounted for by the DVs, by set of DVs. The proportion of variance in DV accounted for by our IVs. How many variance in our DV explained by the set of IVs in our model. Okay, so for in this case, we can say that 13.4% of variance in philanthropic behavior has been explained by avoidance copying and task-oriented copying. Okay, 13.4% of the variance in philanthropic behavior has been explained by avoidance and task-oriented copying. Okay. Next one. Okay, the adjusted R-square value is an accurate value for the sample drawn, but it considered an optimistic. Sorry, the R-square value yang kita report tadi tu is an accurate value for the sample drawn, but it's considered an optimistic estimate. So therefore, for some researcher, they may prefer to use adjusted R-square, in which we consider it to be a better population estimate. And is very useful in comparing the R-squared values between the models with different number of independent variable. Okay, for example, later on, another study being conducted, okay, another quite similar, but different in terms of the number of IV. So then they probably prefer to make comparison based on the adjusted R-squared rather than using the R-squared. Okay. Okay, the next table, the Anova table, it will provide the result for overall regression model. Okay, so based on the table ni, what we interested with is the F and significant F value. Okay, so based on the criteria that I've already shared, okay, if the significant F lesser or equals to alpha 0.05, so we reject the hash not. Okay, but if let's say the significant F larger than alpha, we fail to reject hash not. Okay, so based on our data set, the F equals to 4.427. which is quite large, okay, and then our significant value is 0.016, okay, in which it is very small compared to 0.05. So therefore, we can have the conclusion in mind that the regression model fits the data. Okay, our regression model fits the data. We can have the idea that at least one of the IV contributes significantly to the DV. At least it can be both, but at least one. Okay. Okay, so next we refer to the coefficient table. Okay, the coefficient table will provide result for individual contribution. Based on the overall contribution, we know that our model contributes significantly to the DV, but we do not know which variable, which IVs that contribute significantly. So then we refer to the coefficient table. Okay, so based on the coefficient table, okay, we check for the individual contribution. Again, the unstandardized coefficient will be used in prediction equation. Okay, so earlier we developed our general prediction equation. Now we just need to plug in the value into the equation. Okay, so the constant that we have here is 3.05. Okay, for B1, 0.315 X1, and then for avoidance or X2 is negative 0.16. So we plug in the value into our equation, make our equation as y hat equals to 3.05 plus 0.315 X1 minus 0.16 X2. Okay, so based on this prediction equation, we can say that for 1 unit increase in task-oriented copying, philanthropic behavior will increase by 0.315 units. Meanwhile, for 1 unit increase in avoidance copying, philanthropic behavior will decrease by 0.16 unit. Okay, that's how we can interpret the the unstandardized coefficient values. Okay, so next one, standardized coefficient beta. Okay, standardized coefficient beta ni we can use to describe the individual contribution. How much is the variance attributed by that particular IV? Okay, so in this case, for task-oriented copying, okay, the standardized beta is 0.34. So we can conclude that 34% of variance in philanthropic behavior is contributed by task-oriented copying. Meanwhile, 13.5% variance in philanthropic behavior is contributed by avoidance-oriented copying. Okay, for the standardized coefficient beta, okay, regardless of the direction, either positive or negative, we just describe the value regardless of the symbols in front of the value. Kita tak baca simbol tu, kita baca nilai dia sahaja. Okay. Okay, so based on this value also, we can determine the best predictor. Okay, we can determine the best predictor. So based on the case, regardless of the symbol, either negative or positive, we can conclude that the best predictor is task-oriented copying, because the number of variance accumulated by this variable is higher compared to avoidance-oriented copying. Okay. Okay, next one is to determine to describe the significance of individual contribution. Just now, we already described how much the contribution of the individual variable. Okay, now we want to see either the contribution is significant or not. Sometimes, okay, the result indicate that the variable contributed, but it is not significant. Possible, Okay. So to see or to determine either the contribution is significant or not, we need to report both T and significant T values. Okay, so based on the result, okay, the T value for task-oriented copying is 2.757. The significant value is 0.008. which is we compare the significant value against the alpha, which is, for example, if you use the alpha equals to 0.05, so this value 0.008 lesser than alpha 0.05, so we can conclude that the influence of task-oriented copying on philanthropic behavior is significant. Okay, but the result for avoidance, since the significant T for avoidance-oriented copying is 0.279, which is larger than alpha 0.05, so we conclude that there is no significant influence of avoidance-oriented copying towards philanthropic behavior. Okay. Okay, next, another option to see on to determine the significance of the influence, we can refer to the 95% confidence interval for beta. So if how to determine, it is based on the location of 0. If 0 located outside the range of lower bound and upper bound, so the result considered to be significant. But if 0 located inside the range of lower bound and upper bound, so the result considered not to be significant. So the findings are consistent with the significant T, which is we can determine only task-oriented copying has significant influence towards the philanthropic behavior. Okay, so the two finding here ni kita ignore dulu. Okay, nanti saya tunjuk bila nak pakai. Okay, checking the assumptions, okay, of multi-collinearity. Okay, to check the assumption of multi-collinearity ni, then we refer to the correlation table that we have just now. Okay, so we refer to the correlation table. So now, according to R value, okay, the R value, R equals to -0.009, the correlation between avoidance-oriented copying and task-oriented copying. The R equals to -0.009, which is lesser than the cut-off point presented just now, which is 0.7 indicated the value to be deleted, the case to be deleted. Okay. Then, since the value of correlation coefficient equals to -0.009, which is lesser than 0.79, so therefore we can conclude that there is no issue of multi-collinearity between avoidance-oriented copying and task-oriented copying. So tak ada issue. Okay, then we refer to the collinearity table, collinearity statistic, to check on our collinearity result. Okay, the tolerance and VIF, variance inflation factor. Okay, so tolerance ni, if the tolerance value lesser than 0.1, if the tolerance value lesser than 0.1, it indicates high multiple correlation with other variables. Okay, which is it will indicate the multi-collinearity issue. Kalau the tolerance value to lesser than 0.1. Okay, but if we refer to the VIF, variance inflation factor, which is it is the inverse, it is an inverse of tolerance, 1 divided by tolerance, meaning that if the VIF larger than 10, it is indicate the multi-collinearity issue. Okay, dia terbalik daripada tolerance. Okay, so in our case, okay, so the tolerance value equals to 1. Meanwhile, the VIF equals to 1. So we can conclude that there is no issue of multi-collinearity according to the tolerance and VIF. Okay. Clear eh? Untuk multi-collinearity, clear? Okay, next one. Collinearity Diagnostic. Okay, so we refer to the condition index. Condition index greater than 15 indicates a possible problem. Okay, if the value ni greater, if the condition index greater than 15, it indicates a possible problem. Okay, maksudnya ada case yang kita kena tengok. Okay, an index greater than 30 suggests a serious problem with collinearity. Therefore, it must be adjusted or must be deleted. Kalau 15 tu possible problem. Tapi belum mungkin kita boleh include lagi. But kalau larger than 30 and above, so we need to delete the case. Okay, next one, outliers, normality, linearity, homoscedasticity, and independence of residual can be interpreted based on PP plot. Kita ada PP plot kan dalam tadi kan? Dan finding kita ada PP plot tak? Do we have the PP plot? Semua diam lah.
Ada doktor dekat bawah.
Ada. Okay, so we refer to the points in in our graph. Okay, the points lie in a reasonably straight diagonal line from bottom left to the top right. Kita tengok ni line kita the dotted data ni memang terletak cantik je dekat straight line. Okay, so this suggests no major deviation from normality. Maksudnya tak ada isu normality lah based on the data set. Next one, okay, the scatter plot. The scatter plot ni it indicates the residual roughly rectangularly distributed with most of the scores concentrated in the center along the 0 point. Kalau kita tengok ni most of the data set ni located 0 ni, dekat 0 ni. Tapi dia punya range ni -2 plus 2 lah kat sini. Ada yang 2 ni possible outliers kat sini. Okay. This one according to scatter plot. Okay. So this one the value more than 3.3 or less than -3.3 considered to be an outlier. So most of the data set centered at the 0 location, centered at 0, but still all the data ni still within the range of plus minus 3.3. So there is no issue of outliers kat sini, residual ni. Next one, detect outliers from Mahalanobis distance. I'm sure that some of you already learned or heard about the Mahalanobis ni in your statistics class. Okay, now to check on the value ni, you can go to your data set. At the end of your data set tu, you all akan ada beberapa lagi the addition of a column that has been added in your data set after you run the previous analysis. Betul tak? Ada tak? First ni, the Mahalanobis, mah_1. Okay, result for Mahalanobis distance. Ada tak? Ada. Okay, good. Okay. To determine the the outliers from the Mahalanobis distance, first we need to arrange our data ni. First, we determine how many independent variable will be included in your multiple regression analysis. Okay, so in our case, we have 2 IVs. Okay, we have 2 IVs. Okay, so find this value in one of the shaded column. Dalam shaded column tu, number of independent 2. Okay. So then the critical value or the cut-off point for 2 IVs is 13.82. Itu dia punya critical value. Okay, read across the adjacent column to identify the appropriate critical value, which is 13.82. Okay. So we go to the summary, the result of summary in our output. We check on Mahalanobis distance column. Kita tengok. Okay, the minimum is 0.019, the maximum is 7.978. Maximum Mahalanobis distance value for this data is 7.978, which is still lesser than 13.82. Okay, so therefore we can conclude that there is no issue of outlier. Tak ada outlier. Okay. Okay. Then if you want to check by case, this one, they summarize. If you want to check by case, okay, to check by case, you choose option sort cases. Pergi dekat you all punya SPSS tu, dia ada option 1, option sort cases. Data sort cases. Jumpa tak? go to data, click sort cases. Pick this one. Okay. Click data, click sort cases. Okay. Then sort ni, you choose, saya punya tak ada kat sini sebab saya dah delete. Choose the mah_1. Okay. Choose mah_1 and sort by. Okay. Locate under sort by column. Boleh? Boleh? Okay. And then sort order up to you. You can use ascending or descending order, up to you. But I use descending. Okay, and then click OK. So it will arrange your data in descending order. Okay, so 7 from larger to smaller Mahalanobis value. So the largest is 7.97755. So sama je sebenarnya daripada summary tadi. Okay, similar. Okay, so the case with the largest mahal distance, value will now be at the top of the data file. Okay, senang je kan? Okay, clear Any question? Okay, next one. Detect outliers from Cook distance. Okay, kita guna Cook distance. Okay, you refer to the residual statistic tables. Okay, refer to the Cook distance column. Okay, in which the minimum value is 0.000, the maximum is 0.089. The cases with values larger than 1 are a potential problem. Kalau untuk Cook distance, the cut-off point is 1. Okay, if for Mahalanobis distance, the cut-off point is depending on the number of IVs in our data, in our model. Okay, but for Cook, the cut-off point is 1. Okay, so to check the result for Cook distance appear, okay, the Cook distance we refer to the COO_1. Okay. Okay, so then we go back to check by case. To check by case, same goes to the how we check the Mahalanobis distance. We go back to our data view. Okay, then we sort the case. So we click data, we click sort cases. Click data, click sort cases. Okay, then now you choose the Cook distance. Cook COO underscore one. Bukan kuku ku. Saya nampak ku tu tengok kuku. Okay, and then pick sort order, descending sort order. Okay, and then click OK. So now you have your Cook distance. Arrange according to descending order. Okay. So now the maximum also 0.089, still lesser than 1. So we can conclude that there is no issue of outlier. Okay. Okay, any questions so far? So semua okay. Semua okay. Based on the data set tu semua okay. Okay, so then we set our alpha 0.05 or 0.01, then we make the decision accordingly. Ini sebenarnya kita dah siap dah pun. Okay, so the conclusion either we reject or fail to reject our model, our overall model. Okay, if we reject, so means that none of our IVs contributed to the if we reject the null hypothesis, means that at least one of our IVs contributed significantly to the DV. If we fail to reject, meaning that none of our IVs contribute significantly to the DV. Okay. So this is yes.
Doctor, we need to do both. We need to do both the checking. Is it Mahalanobis and also Cook, or we can just choose either one?
You can choose either one. You can choose either one. Okay, you can choose either one. Okay. Okay. So next one that you data that you can report in your finding include the R-square, in which it is related to the amount of variance in Y explained by X. Okay. So the value of R-square will be ranged from 0 to 1. The smallest is 0, the highest is 1. But the way we interpret is in percentage form, dalam bentuk percentage. Okay. Meanwhile, multiple correlation coefficient, okay, we report the value but we do not interpret. Okay, kita tak interpret. Okay, the range for multiple correlation coefficient value also within 0 to 1, 0 smaller, 1 largest. Okay, and then another thing that we can report is the effect size. We know the amount of variance, we know the result is significant, but we want to know how much is the size. Is it small, medium, or large? Okay, the influence ni. So then we report the coherence effect size in which the equation is f squared equals to r squared divided by 1 minus r squared. Okay, so we just plug in the value. Kenapa dia tak keluar ni? Tak apalah. Okay. This one, the slope ni will determine the individual contribution. Tadi kita dah buat pun. Okay, the individual contribution tadi. Okay, so make sure you state your research and null hypothesis for the individual contribution. So for example, for null hypothesis for task-oriented copying, we indicate that there is no significant influence of task-oriented copying on philanthropic behavior, and our research hypothesis, there is a significant influence of task-oriented copying on philanthropic behavior. Okay. So now we extract the significant T and significant T value. Okay, in terms of reporting, make sure you report both. Report both in your dissertation as well as in our exam letter, in your assignment as well. Make sure you report both T and significant T, even though the basis of making decision is only based on the significant T. Okay, so based on our analysis just now, the T equals to 2.757, significant T equals to 0.008. Okay, then we set our alpha. Okay, then we make the decision. Okay, the decision criteria, please remember. I hope that there is no issue lah to remember the decision criteria. Okay, so since our significant T equals to 0.008, which is lesser than alpha 0.05, so we reject hash not. Okay, we conclude that okay, our task-oriented copying contributes significantly towards the philanthropic behavior. Itu kita punya finding. Okay, and then to report the effect size, we just need to plug in the value into the equation. So r squared just now is 0.134. So 134 divided by 1 minus 0.134, so equals to 0.155. Okay, 0.155. So according to the Coherence table, Coherence effect size table, okay, 0.155 indicate the medium effect size. Okay, so the influence of both IVs ni towards the DV considered to be medium. Okay. Okay, so then to come up with the prediction equation, this is our prediction equation. Okay, for example, you were given the value. Okay, for example, you were given x1 equals to 5 and then x2 equals to 3. So please calculate y. Berapa? Kalau x1 equals to 5, x2 equals to 2. 2 ke? 3. Berapa? What is the answer? Siapa-siapa kira tak? Saya tak ada kalkulator lah pula dengan saya ni.
X1 5 kan doktor?
Yes, x1 5, x2 3. 4.145? Betul? 4.145. Betul ke?
Betul.
4.145 contoh. Okay. Okay, so this is how to read the unstandardized beta value. Okay, for every 1 unit increase in task-oriented copying, philanthropic behavior will increase by 0.315 units, and for every 1 unit increase in avoidance-oriented copying, okay, philanthropic behavior will decrease by 0.16 units. Okay, according to the graph here, we can see that there is a positive relationship between task-oriented copying. So this one on orange ni is task-oriented copying. Okay, task-oriented copying and philanthropic behavior. Meanwhile, for avoidance-oriented copying, okay, so if the volunteers apply the if let's say the personality of volunteers ni is more on avoiding the conflict, so the tendency for him or her or him to maintain as a volunteers ni will be reduced. Itu maksud dia akan berkurang, tendensi lama-lama tu hilang, berhenti. Okay, so R squared equals to 0.134. So according to the value, again we can conclude that 13.4% of variance in philanthropic behavior is explained by both TOC and AOC. Okay. Okay, in terms of reporting the result according to APA style, we can say that a multiple linear regression was conducted to predict philanthropic behavior based on task-oriented copying and avoidance-oriented copying. Okay, a significant regression equation was found. So F, okay, equals to 4.427, significant F equals to 0.016. With an R squared of 0.134. So prediction equation obtained from the result is Y equals to 3.05 plus 0.315x1 minus 0.16x2, where Y equals to philanthropic behavior, x1 task-oriented copying, and x2 avoidance-oriented copying. So according to the prediction equation, 1 unit increase in task-oriented copying results in 0.315 increment in philanthropic behavior, and 1 unit increase in avoidance-oriented copying will reduce philanthropic behavior by 0.16 unit. So further analysis on effect size indicated that the effect size is moderate, okay, or medium. Okay, medium. Okay, which is F squared equals to 0.16. So in terms of APA table, okay, so table 1, multiple linear regression analysis between copying strategies and philanthropic behavior. So we include the model, constant, task-oriented copying, and PB, AOC, and PB. We report the unstandardized coefficient, standardized coefficient T, and significant T. Okay, and then we also report the multiple correlation coefficient, okay, coefficient of determination, F value, and significant F below the table. Okay. Okay, next question.
Doktor, mana doktor dapat nilai X1, X2 tadi?
X1.
Dan untuk apa kita dah dapat nilai Y tu, ada nak guna kat mana-mana tak nilai Y?
Okay. So what the purpose of calculating the X? Macam mana saya dapat 5 and 3? 5 and 3. Okay, 5 and 3 ni basically we use the okay, first when we conduct the study we want to come up with the prediction equation. Prediction equation ni, if in business we use to make prediction for future occurrence. So we come up with prediction equation because we want to predict the occurrence of the philanthropic behavior ni. Faham tak? The 3 and 5 tu the value yang saya letak aje. Okay, but if let's say in future, if we want to predict in the area of volunteerism, we want to predict the occurrence of or the tendency of people or volunteers to keep maintain in volunteerism activity. So we can use this equation to make prediction. So therefore kan, maksudnya bila kita nak cari volunteers yang nak contribute continuously to the organisation, kita akan cari orang yang ada task-oriented copying compared to avoidance-oriented copying. So meaning that we need to develop copying skill lah. Sebelum jadi volunteers, then we run the copying, we conduct the copying survey among the volunteers. So kita boleh tahu dah orang ni akan stay lama, orang ni mungkin akan hilang nanti unless we do some training for them to make sure that they change their copying style ni from avoidance to task ke atau emotion ke, macam tu. Okay, sebenarnya based on prediction equation ni we can develop more alternative or strategies either to maintain that particular people within the organisation. Itu contoh. Itu dia punya purpose for prediction equation ni. Okay, biasanya ni kalau dalam sale ni dia digunakan untuk predict sale. Kalau kita ada pemboleh ubah ni dengan ni, so berapa sale kita dapat. Contoh
Tapi untuk writing kita tak ada nak discuss further lah kan?
Kita discuss further lah. We just present the prediction equation, then we'll elaborate. Tapi kita tak adalah ni. Kita tak adalah masukkan value and so on. Apa yang kita nak sebenarnya inilah dia finding ni. Ini penting sebenarnya finding ni. Okay?
Doktor satu lagi. Tadi doktor kata jangan interpret R value sebab dalam contoh-contoh notes sebelum ni macam ada yang interpret R value guna Guilford tu sahajalah. Dia tak jauh.
Dia sebenarnya because based on multiple correlation coefficient, kalau if we run the correlation analysis, we know that the relationship is based on the individual IVs and DV. Kan, betul? Kita tahu, but in multiple linear regression, the R ni, the multiple correlation coefficient ini dia indicate the overall, in which it is meaningless for us to elaborate. Meaningless. Kita nak elaborate ni hubungan dia dengan apa, antara apa dengan apa. Right, because we do not know the individual relationship tu. Dia just dia buat apa tu, the result is lump sum, semua sekali dalam tu. That's why biasanya kita tak elaborate pun. Kalau elaborate tu sebenarnya something wrong lah.
But yang contoh dia elaborate ni, dia kata based on Guilford rule of thumb, there is a high relationship between the two predictors. So disebutlah predictors berapa dengan DV. So tak perlu
Tak ada. Itu biasanya kalau kita jumpa tu kita akan gelak dululah. Biasanya kita tak elaborate in lump sum macam tu dalam in overall macam tu. We elaborate the correlation value ni according to the variable. But kalau kita elaborate in overall like that, we do not know the direction pun. Macam fair ke kita nak lump sum kan macam tu, sedangkan based on individual relationship, avoidance oriented copying ni negatively correlated, sedangkan task oriented copying ni positively correlated. So we miss that information. Okay. Okay, any other question? Yeah. Okay, so if no question,
Dr. Rami.
Ya, saya.
According to Baki's question, then kalau kita tak interpret R, so kalau katalah let's say lah kita punya hypothesis to determine relationship, then kita conduct person lah.
Yes, we refer. Okay. Okay, to determine, if let's say you have the objective on to determine the correlation, correlation. If you use the term correlation, you can either use the result from Pearson or from multiple linear regression, either one. But if you use the term association to determine the association between IV and DV, so this one mostly close to Pearson. Faham kan? Term tu sebenarnya dia ada connection dengan the type of statistical analysis. Kalau if you use the association, then this one for sure it is connected to Pearson product moment correlation or Spearman rank order correlation result. But if you use relationship, the term relationship ni it may provide you with two options. Either you want to use the result from Pearson or multiple linear regression. Dua-dua boleh. Kalau influence, biasanya kita akan pakai multiple linear regression. Okay, ataupun to determine the most dominant variable, for example. To determine the most dominant variable, then we can use the result from multiple linear regression. Term tu Okay, dan
Sebenarnya macam banyak benda nak tanya tapi tak tahu nak tanya.
cuba tanya satu-satu.
Betul, just sebab nak faham. Before this, nanti doktor akan share juga kan video ni kan sebab kena hadam balik.
Share.
Just nak confirm the reason why kita tak interpret the R because kita interpret in Pearson each one kan ke betul?
Yes.
Sebab kita dah interpret in Pearson each one, so no need lah kita nak interpret the MLR kan? In
Betul.
MLR only the report, betul?
Betul. So in MLR, what we are interested at is actually the finding from the finding for overall model as well as the individual contribution. Okay, the result of descriptive, the correlations ni, we just use to describe the issue of multi-collinearity, linearity, that's all. We have no other interest kalau untuk multiple linear regression. Because for regression ni, macam saya kata tadi kat Balkis, what the purpose of describing the overall correlation? Apa dia punya purpose? Sebab we cannot determine the direction of the relationship based on the overall value. Kita tak tahu pun. Sedang buat apa kita nak tahu the overall relationship tu? Kan kita nak what we want to learn is about the individual correlation, individual connection between the IV and DV. Sebab tu kita tak report dalam MLR because we already report in in Pearson. Okay. Dan biasanya if the result is significant, in MLR, for sure the result also significant in Pearson. Tapi kalau significant in Pearson, not necessarily significant in MLR lah. Okay.
Doktor.
Yeah.
But in case for R, for interpreting R or elaboration of R, untuk simple linear kita elaborate kan sebab dia 1 DV and 1 IV.
Okay, dia sebenarnya sama. Even in SLR pun we are not interested to interpret, but since the value to should be similar with the result from Pearson, so then you can use that one to elaborate. But again, it will not provide you with the direction of the relationship. It just provide you with the value, tapi tak ada direction pun. Faham? Dia tak ada direction pun. Faham Sebab tu, to reduce your confusion when you develop your hypothesis, sebenarnya try to differentiate between the objective for Pearson and the objective for regression. So then, for hypothesis, you can develop the hypothesis ni for one statistical analysis. Either you want to choose regression or correlation, up to you. Tapi the objective tu, you differentiate between the objective for Pearson, the correlation, and then the objective for determining the best predictor. You all ada dua objektif yang berbeza. Supaya you all nampak lah apa beza dia. Kat mana nak report kat mana. Okay, boleh? Lagi soalan? Ada lagi? By the way, just to inform everybody, next week we are not going to have any lecture minggu depan sebab saya ada bengkel minggu depan. Minggu ni kita masuk ni dulu. Saya habiskan mana yang berkait dulu. Any question? Any other question? Nanti saya akan cover balik, moderation tak sempat kot hari ni. Saya akan cover balik dua lagi topik, which is chi-square and two-way ANOVA. Dua lagi hutang.
Doktor nak ulang balik. Kiranya dekat Pearson, kita report direction, positif atau negatif tadi tu, dengan strength. Betul?
Betul.
Dua benda. Okay. Lepas tu dekat MLR, kita ada equation tu. Dan yang mana contributes more kepada DV kita?
We report the regression equation, we report the overall model F and significant F, and then we report the prediction equation to reflect the unstandardized coefficient beta, and then we also report the standardized beta, and then the significant, the individual contribution. Itu yang kita report dalam
Lepas tu dia tak ada conclusion apa ni high relationship tu dah takkan sentuh dekat MLR.
no.
Oh.
So that's why we use effect size instead. Sebab dekat in MLR we want to know which variable that contribute significantly. Ni contribute tau. Tadi correlated significantly, but this one contribute significantly, and we want to determine among the IBs which one that has that become the dominant predictor yang paling contribute paling banyak.
Yang variance paling tinggi lah kan.
And then kalau let's say you all rasa macam nak cari yang benda yang hampir sama dengan R tu, then you can report effect size. Effect size ni will conclude both contribution, the contribution of both IVs, the size, how much is the size of their contribution. Dia lagi meaningful, lagi strong compared to R. Okay, effect size ni dia determine how much is the effect of IVs ni, the set of IVs towards the DV. Dia lagi meaningful compared to multiple correlation coefficient.
Effect size tu kira dekat Pearson, bukan dekat MLR.
MLR.
MLR kan, Pearson tak ada effect size kan?
Tak ada. Okay?
Effect size value dia sampai berapa doktor?
Effect
dia
size
memang besar.
Dia boleh jadi besar.
Okey, dia tak ada infinity lah, dia tak adalah sampai had berapa-berapa kan?
Tak ada. Okay? Lagi? Ada Okay. So,
Doktor, Doktor,
yeah.
to determine the most dominant or most dominant or predictor dekat dalam MR, kita lihat kepada value of P, significant value.
Kita tengok dekat standardized beta. Okay, T and P value ni we want to determine either the contribution is significant or not. Kita nak tahu significant ke tak. Okay, kalau unstandardized beta we use in equation. For standardized beta ni, standardized beta ni we use the value, okay, to describe first to describe how much variance contributed. The second one we can determine which one is the most dominant. Kalau value tu semakin banyak, the variance that explained by the IV ni, maksudnya dia adalah the most dominant contributor to the DV. Boleh Hafiz?
Okay, Doktor.
Okay. So ready tak masuk mediation sikit? Okay. Bismillahirrahmanirrahim. Introduction je. Okay, so so introduction to mediation and moderation analysis in Ibm Spss. So ni kita guna Ibm Spss je. Basic je. Okay, so this is our LO. Okay, at the end of the session, student get to know the basis of mediation and moderation, differentiate between mediator and moderator, and then determine the requirement for mediation and moderation analysis, and then run the mediation and moderation analysis in Ibm Spss. Okay, so ini kita slow and steady je sebab ni dia sebenarnya high level. Okay, tapi some of you already apply this analysis in your research. Sebenarnya tak susah pun, senang je. Okay. Okay, so these are among the statistical analysis that you can use mediation, you can apply or run the mediation or moderation analysis in that software. Okay, we have the Ibm Spss, Smart PLS, okay, SAS, M+, and MOS. Okay, SAS and M+ ni SAS memang saya tak pernah pakai. M+ pernah. Okay, tapi dia sedikit nampak kompleks, tapi bila pakai tu senang. Okay, Ibm Spss biasanya memang terkenal di UPM lah. Okay, Smart PLS ni dia hampir sama dengan MOS in which it runs the mediation and moderation analysis for more than one variables. Apa dia panggil dia run analysis tu sekali. For Ibm Spss, if you want to run the regression and moderation analysis ni, we need to run the analysis according to variable one by one. Okay, one by one. Okay, but in Smart PLS and MOS ni we can run the analysis simultaneously. Sekali je kita buat, kita akan dapat result terus. Okay, and then it can provide you with the analysis in diagram, in illustration form, in which it is more interesting lah. Kita akan nampak gambar tu, the result tu dekat screen kita je. Satu screen, dia akan keluar terus. Okay, tapi in Ibm Spss ni dia still keluar dalam bentuk output biasa. Kadang-kadang kita rasa boring dah. Okay. Okay, so mediator. So what is mediator? Mediator ni ataupun the mediation, mediation occurs when the observed relationship between two variables is due at least in part to a third variable. Biasanya the correlation or the connection between IV and DV ni happen is actually due to or at least contributed to by the third variable. Because in social life ni we cannot conclude that the relationship between the two variables ni is solely because of that IV. Tak boleh dalam dunia sosial ni. Takkanlah kita stress tu sebab attend kelas saya je. Contoh, kan? Boleh jadi stress tu sebab kawan, boleh jadi, ataupun stress tu sebab connection. Contoh. Okay. So a type of regression analysis where a variable, for example, the mediating variable reduce or increase the magnitude of the relationship between two other variables. So bila adanya mediation ni, there will be a tendency for the mediator to reduce or increase the amount or magnitude of the relationship between IV and DV. So meaning to say, before we are able to run the analysis, the mediation analysis, the IV and DV ni at the first place memang dah ada hubungan. Dia memang dah ada hubungan dah. IV dengan DV ni memang ada hubungan. It just maybe a certain amount of the relationship ni happen due to the third variable. Okay? Okay, to test hypothesis about how some causal antecedent variable X transmits its effect on a consequent variable Y. Okay, so kalau tadi sampai multiple linear regression, okay, it's still not the analysis is not yet considered to be causal relationship. Okay, analysis of correlation multiple linear regression ni dia belum lagi merupakan satu analisis yang menentukan cause and effect. Okay. But start from mediation and moderation, these types of statistical analysis ni is known as cause and effect statistical analysis, in which if we apply this analysis, we can determine the cause, which one is the cause, which one is the effect, the cause and effect relationship, the causal relationship. Okay, so mediation is a type of causal relationship. Okay, and then the mediator can be any hypothesized psychological, okay, social or biological variable through which X may influence Y. So meaning to say mediator can be any variable. Okay, boleh jadi apa-apa sahaja variable, possible. Okay. Okay, intermediate in the causal sequence relating an independent variable to a dependent variable. So kalau kita illustrate dia punya hubungan, so dia terletak di tengah-tengah, intermediate. Okay, IV, mediator, dependent variable. Okay, in terms of the flow of relationship ni start from IV, influence mediator and influence the variable. Okay, so kalau kita tengok from this simple illustration, we can in our simple mediation model. Simple mediation model ni means that you have one IV, one DV, and one mediator. Simple mediation model. Okay, so in this simple mediation model illustration, we can see or we can determine that we have two IVs and then we have two DV in our model. Betul tak? Betul tak? At the first place, when we determine the relationship between IV and mediator, so mediator becomes the DV. Right? So this one memang DV lah. And then when we want to determine the relationship between mediating variable and dependent variable. So this one will change and become the IV, and this one DV. So we have 2 IV and then 2 DV. Betul kan? Betul Okay. Kenapa saya stop pula? Mana pula cursornya? Okay, so the purpose of using the mediation analysis is to determine the mediating role or effect of the third variable in the relationship between IV and DV. Okay, so in terms of the application, okay, we might interested to ask what is the mechanism, either be it emotional, cognitive, or biological, or otherwise, by which X influence Y. So we want to determine the third variable in the relationship between the two. Okay, so for example, does social network increase the likelihood of social trust? X influence on philanthropic behavior Y, because a trustable person tend to have larger social network, which in turn influences their behavior to help others. This one according to social identity theory and social exchange theory. Kalau seseorang tu jenis yang mudah dipercayai, dia akan ramai kawan. Bila ramai kawan ni, dia akan banyak social interaction, and then possibly they have friends that are connected to any NGOs that may attract him or her to involve in volunteerism activity as well. Ini contoh according to theory. So meaning that to apply the mediation analysis ni, make sure you have one theory that prove that your IV is connected to your DV. Kena ada teori ni. Okay. In terms of the requirement, the IV must be possibly continuous or dichotomous. Okay, tapi dalam ni saya rasa saya tunjuk continuous sahaja. Okay, dichotomous ni dia kompleks sikit. Okay, and then for mediator variable, it must be in continuous scale of measurement and must be normally distributed. Okay. For DV, okay, continuous scale of measurement and must be normally distributed. Dua-dua. So IV je boleh jadi dichotomous, boleh. It can be categorical or continuous variable. Okay. Okay, so this is the illustration of simple mediation model. Okay, we have our IV, we have mediator, we have DV. So the arrow ni comes from two ways. Either come first direct from IV to DV or through the mediator. Okay, so at least one causal antecedent X variable is proposed as influencing an outcome Y through a single intervening variable M. So M ni considered to be the intervening variable. Okay, we have two consequent variable, which is M and Y. Consequent ni macam DV lah And then two antecedent variable X and M. X, M. Okay, which X causally influence Y and M causally influencing Y. Okay, dua-dua Okay. Regression models in mediation analysis. This one in general In general, this is the simple mediation model. But to run the analysis, we need kita kena pecahkan dia satu-satu. First, we look at the first part from the model, which is the relationship between IV and DV without mediator. So this one, X to Y simple regression model. So to get the result ni, first we need to run the simple regression analysis. Kita pecahkan satu-satu yang ni Second one, okay, the relationship, the influence, okay, of the relationship between IV and mediator and DV. So we can run the multiple linear regression. So this one, we need to run the multiple linear regression. Okay, XME towards Y regression model. So this is the second model. The third one, the IV, the influence of IV towards mediator. Okay, which is X and mediator simple regression model. Okay, so we need to run 3 different regression analysis. Okay.
Doktor, sorry. Untuk mediation dengan DV tu tak perlu buat SL, tak payah buat simple linear regression untuk mediation dengan DV.
Mediation dengan DV. Sebab kita dah buat kat sini. Sebab yang ni
Ini
boleh buat
direct terus
sekali.
pada multiple lah, tak perlu buat
Betul.
simple linear regression.
Betul. This one multiple. Okay. Okay, next one. Okay, so a simple mediation model is in any causal system in which at least one causal antecedent X variable is proposed as influencing an outcome Y through a single intervening variable M. Okay, so there are 2 pathways by which X can influence Y. First, the pathway leads from X to Y without passing through M tadi. Maksudnya daripada bawah tadi X direct to Y. The second pathway from X to Y is the indirect effect. Yang tadi dan the influence of X to DV through M, then we know as indirect effect. Tadi yang kat bawah direct tu the name is direct effect. Yang atas tu indirect effect. Okay, so ini dia punya explanation dia. It first passes from antecedent X to consequent M, and then from antecedent M to consequent Y. So the indirect effect represent how Y is influenced by X through a causal sequence in which X influence M, which in turn influence Y. Okay. Okay, so ini dia punya model. First, IVDV. So we use the name for path. First path ni C prime. Okay, so C prime. Second one, from IV to mediator. Okay, the path, the name is alpha. And then mediator to DV. So we use beta. Okay, and last one, IV to DV without control. Without control for mediator, the name is C, path C. So dia ada A, B, C and C prime. Okay. Where C prime equals to direct effect. So this one direct. Okay. AB, A times B, indirect effect. AB plus C prime equals to total effect. AB, A times B plus C prime equal to total effect, which is equal to C. Okay. Ni tak apa, ni laju dah. Ni dah faham tak apa. So the requirement in terms of scale of measurement, again DV, tadi saya kata dia boleh jadi dua-dua tapi ni saya letak interval or ratio. DV ni must be interval or ratio. IV ni dia boleh jadi continuous or dichotomous. Mediator, interval or ratio. Okay. And then to run the mediation ni, it require large sample size. Large ni large lah. Large. Okay, more than 100 basically. But if you run the analysis by using a certain a particular software, for example MOS, okay, the minimum requirement to run the mediation in MOS is 250 respondent. Baru cantik. Nak betul-betul itu minimum. Kalau nak betul-betul cantik 300 and above respondent, baru model you all akan cantik. Tapi dalam SPSS ni dia less stringent sikit. Kalau pakai SPSS less stringent, okay? And then then this one when you refer to the technique to determine your sample analysis, to determine your sample size ni, you need to look for reference that specifying on the use of mediation as well as the statistical software. Kalau you all nak pakai MOS, then you all kena cari justification. If you want to use MOS, how much is the sample size? That's why to determine the sample size ni, it can be based on a lot of criteria. Dia bukan satu, banyak benda. Even software yang kita nak pakai pun can become one of the criteria to determine the sample size. Okay? Okay, assumptions. First, the independent, mediator, and dependent variables are normally distributed in the population. Okay, and then the cases represent a random sample from the population. Okay, dua kriteria je. Okay, simple. Okay, first total effect. Total effect ni referring to the original relationship between X and Y. Hubungan asal dia. Okay, without controlling for any variable. Okay. Okay, and then direct effect referring to the X to Y relationship after we remove the indirect effect that goes through the mediating variable. Meaning that in our analysis, we need to control the influence of mediator when we run the analysis of IV and DV. And that's why we need to run the analysis separately, IV, DV ni. Okay. Okay, meanwhile, the indirect effect ni referring to the path from alpha, beta, IV to mediator and mediator to DV. Okay, so the effect of X on Y through M. Okay, the direct, indirect, and total effect. So this is the direct model. C, just reflect the total effect. Mediation model. Okay, A, B, C prime. Okay, jangan confuse Yang ni direct model ni referring we measure the total effect. In mediation model we measure the indirect and direct effect. Okay, direct ni direct model, ni direct effect. Lain Okay. First, ni step sama. Okay, state H0 and HA, extract significant F ni tak apa, sama. Okay, first we state the research and null hypothesis. For example, there is an insignificant mediating effect of mediator in the relationship between X and Y. And then our research hypothesis, there is a significant mediating effect of ME, mediator in the relationship. So ini contoh. Okay, kalau you all nak guna the statistical form, then H0 alpha beta equals to 0 or HA. HA ni. Bukan, sekejap. Okay, HA equals to HA alpha beta not equals to 0, or okay, we can say that the relationship between entrepreneur's economic stress and withdrawal intention was not mediated by difference effect, or our research hypothesis. Okay, the relationship between entrepreneur's economic stress and withdrawal intentions was mediated by depressed effect. Ini contoh Okay, so to extract test statistics. Okay, so now we need to run the analysis in Ibm Spss and extract the important statistic to be reported. Okay, so sebelum kita run the analysis, I want to share the two strategies to run mediation analysis in Ibm Spss. There are two school of thought. Sebenarnya banyak, tapi saya highlightkan dua sahaja. Okay, if you go through the literature and you look for the mediation notes, nota berkaitan dengan mediation, the first note that you will be directed to will be article by Baron and Kenny 1986. Ini yang memang lama, the first school of thought. Ni yang awal-awal diperkenalkan. But recently, okay, Pritchard and Hayes also introduced their school of thought and argue, okay, related to the Baron and Kenny technique. Okay, but we learn both. Okay, kita tengok dua-dua. Okay, so mediation effect according to Baron and Kenny 1986. Okay, so dia kata a variable has mediated the relationship between two other variables when the basic relationship is reduced when the mediating variable is included in the regression equation. Dia kata kalau ikut Baron and Kenny ni, satu variable tu akan jadi mediator sekiranya bila variable ni masuk dalam hubungan tu, dia akan mengurangkan amount of the relationship between IV and DV tadi. Okay, dia mengurangkan. Okay, so to determine the mediation effect according to Barron and Kenny, you have to follow 4 steps. 4 steps. First, you need to determine the association between X and Y by running the Pearson product moment correlation analysis. First, run the PPMC between IV and DV to make sure that the relationship is significant. Yang kedua, you run the Pearson product moment correlation between your IV and mediator. Then make sure the result also significant. The third method, you run the analysis of Pearson product moment correlation between mediator and DV. And make sure the result also significant. Okay, and lastly, establish the 3 regression models and compare. Okay, then you can compare lah. Baru bila after you run these 3 steps, only then you can make the comparison. Either the result is significant or not. Either the result, either the amount of influence to reduce or not. Okay, so kita akan gunakan guideline ni nanti. Okay, dia ada 2 model, direct model and mediation model. Okay, based on the table ni, for the direct model, if the direct model significant, okay, and then if the correlation, the effect of X on Y ni reduce in mediation model, the result is non-significant, then we can say, then X on M is significant, M on Y is significant, then we can say that there is a full mediation. Okay, dia ada jenis-jenis mediation juga. Okay, second one, if the direct model significant, but in mediation model, X influence on Y reduce, okay, we reduce, the result is significant, the influence of X on M is significant, and the influence of M on Y is significant. This one indicate partial mediation. Partial mediation. Okay, but if the direct model non-significant, okay, and then for the mediation model ni, kita akan tengok ni dia akan ada 2 tendensi lah, sama ada no mediation or indirect effect. Indirect effect ni hanya X on M, M on Y yang signifikan. 2 ni sahaja yang signifikan, barulah dia akan jadi indirect effect. Okay, ni untuk Barron and Kenny. Okay, so first, to test the first assumption. Tadi first assumption this one ni. Okay, X on Y. Okay, so first to run first procedure, test the assumption. First, click analyze, click correlate and bivariate. Okay, kita run the first assumption, X on Y. Okay, analyze, correlate and bivariate. Okay, then you choose the 3 variables. Choose all the 3. PB mean task oriented copying and social network mean. 3 ni. Tick for Pearson, two-tail and flex significant correlations. Okay, and then click OK. Am I too fast?
Okay.
Okay. So then this is the result. So we got the PPMC result. Okay, so ni the result dia. Okay. So determining the mediation effect. So now kita extract the value. So for 1, X correlation between X and Y. Okay, so ini saya ambil daripada table ni table ni. Okay, so according to the result, the correlation between X and Y equals to 0.383, which is 2 star indicated the significant correlation. So it fulfill the first criteria. Kena correlation IV dengan DV tu mesti significant, wajib. Kalau tak significant, you cannot run the mediation analysis according to Barron and Kenny. Okay. Second one, the correlation between IV and mediator, which is the result indicated R equals to 0.446. 2 stars indicated the significant correlation. So the second assumption pun met. We met the second assumption. The third one, the correlation between mediator and DV. Okay, the result indicated the finding equals to 0.544. 2 stars indicated the significant relationship. So we'll fulfill the third criteria as well. Now the fourth criteria. So barulah kita boleh buat yang keempat. Sebenarnya step yang betul-betul mediation adalah mediation analysis in Barrett and Kenny adalah in number 4 step. Step in number 4. Okay. So then we identify the two model, direct model. For direct model, we need to run the X to Y simple regression analysis. For mediation model, kita kena run one simple linear regression analysis and one multiple linear regression analysis. Okay, dua. Okay, first, X to Y simple regression model. Okay, so to run the simple linear regression analysis between X and Y, you click Analyze, Regression, and Linear. Analyze, Regression, Linear. Okay. Then you include the two variable according to their role. Okay, PB under dependent variable, task-oriented copying under the independent variable. Okay, for the method, we still choose the enter method. And then click OK. Itu saja. Okay, so there we got our finding for the direct model. Okay. So we have, so what we are interested with is the unstandardized value, unstandardized beta. Okay, so our B equals to 0.413. So the result indicated the significant influence as well. Tapi yang kita interested ni unstandardized. Okay, so this is the for the direct model. Done, eh? Done. Okay. Second one for mediation model. Okay, so for mediation model ni, we are interested to know about the direct effect and indirect effect. Okay, so first click, we run the multiple linear regression analysis. Okay, and we click Analyze, Regression, and Linear. Analyze, Regression, and Linear. Okay, under the linear regression box, for the dependent variable, we remain the PB mean. But for IV, we add the social network variable, social network mean. Okay, we include the second variable, which is our mediator, and then click OK. So we got the finding for the influence, the C path and B path. C and B, dapat dua dah. Okay, tadi C prime, tadi C. Okay, ni C prime and B. Okay, so for C prime path, so we have beta equals to 1.186, 189, sorry. So for the B path, okay, we have beta equals to 0.500. Okay. Lastly, okay, we need to run the simple linear regression analysis between IV and mediator. Okay, to run the analysis, we repeat the same step. We just need to change the variables. We click Analyze, click Regression, and click Linear. Analyze, Regression, Linear. Okay, in the regression box, we just change our DV to social network, and then IV we we omit the social network tadi. We omit social network. Okay, and then click OK. So this is the for the A path. So unstandardized beta equals to 0.447. Okay, so now we have the complete model. So this is for the mediation model. Okay, path A beta equals to 0.447. Path B beta equals to 0.5. C prime beta equals to 0.189. Okay, this is for direct model. Tadi bila calculate tadi, apa equation dia tadi? Yang atas tadi. To get C equals to AB plus C prime. Betul tak? Cuba darab, dapat tak? 0.413. 0.447 times 0.5
Dapat.
plus 0.189. Supposedly we got the 0.413. Itu maksud dia. So then based on the direct model ni kita tahu overall, kita ingatkan tak ada pengaruh lain, tapi bila kita pecahkan barulah kita tahu sebenarnya dalam tu ada pengaruh orang lain. Okay, ini interestingnya the mediation analysis. Okay, so now to elaborate, further elaborate or interpret either the mediation, the result ni either full, partial, mediation, no mediation or indirect effect ni, then we plug into this table. Okay, kita buat macam ni. Hypothesis model, hypothesis path, the first path, direct model, we include the beta, standard error, ni unstandardized, ni standardized beta, B ni unstandardized, beta ni standardized. Okay, the T and P. Okay, and then for full mediation model, the relationship between IV and mediator, mediator and DV, and then IV and DV. IV and DV di sini tak sama dengan sini. So this one for the direct model, this one for mediation model. Okay, tak sama Okay, so we compare our finding. Okay, so based on the finding first kita kata first model TOC and PB, the result is significant. Okay, result, the influence of IV towards the DV, the result is significant. Second one, the influence of task-oriented coping to the to philanthropic behavior after we control the mediator. And then we can see the result still significant. Okay, the result still significant, but the unstandardized value reduced. The unstandardized value from 0.413 reduced to 0.189. So we refer to our table. Mediation model X to Y reduce. Sama first ni direct model ni dua-dua significant. Direct model significant. So we have two possibilities. No mediation and indirect effect ni dah bukan dalam decision lah. Okay, so kita ada dua possibilities, either full mediation or partial mediation. Now the value reduce. So kita we still have two options, either partial or full mediation. Next, we refer to the influence of TOC on mediator, task-oriented IV on mediator. Okay, so the result is significant. So X on M significant. So still two options. Kat sini. The significant ni saya termiss kat sini. Okay, reduce. Okay, kalau reduce, if the result non-significant, then this one full mediation. Kat sini tadi. Kat sini lagi. Okay, so we can see the result reduce, the unstandardized beta reduce, but the result here significant. So significant. Once here is significant, so it reflects the relationship is partial mediation, not full mediation. Okay, barulah yang kita tengok yang lain ni dah tak ada, tapi kita dah ada idea lah that the relationship, the type of mediation effect is partial mediation. Okay, yang last ni pun SN on PB pun, SN mediator on DV pun significant. So we can conclude that social network partially mediates the relationship between task-oriented coping and PB. Is there any
Kalau
problem with the table? Ya, Mahfuz.
Ada macam bila kita state HOHA kan, kita just ada kata mediation, we just only mention mediation, but when we get result like this, which one we prefer, full mediation ataupun partial mediation? Ke tak kisah?
Okay, like tadi Mahfuz kata when we state our research hypothesis, we just mentioned that there is a mediating effect of mediator towards in the relationship between IV and DV, betul. Tapi dalam ni kita describe further either it is full mediation or partial mediation, betul macam tu kan soalan dia?
One is we prefer.
Okay. What we prefer is because when we run the mediation analysis, we not yet know either the result will be partial or full mediation. Sebenarnya partial or full ni we just add the flavor in our interpretation. The first we want to determine that there is a mediation. Sebenarnya itu kita punya intention. But now, yes, figure out we managed to find out that our mediator is a significant mediator, and other than it just become a mediator, we further describe that the contribution is full mediation. Full mediation ni maksudnya tanpa mediator ni, the relationship between IV dengan DV ni tak exist. Itu full mediation. Tapi kalau partial mediation ni means that the relationship between IV dengan DV ni it can happen in two situations, either through the mediator or directly to the DV. Dua possibility tu. Okay? Sebenarnya full mediation, partial mediation ni we just add the flavor into our interpretation. Dia lagi cantik dan dapat menarik lagi. Okay? Any problem to read the table, to read the finding from the table? Sebab saya dulu pun saya ada masalah untuk baca table ni. Okay, faham Okay, good. Okay, so this is the interpretation. So we reject the hash null because that indicated there is a significant mediating effect of mediator, which is social network on the relationship. Bukan in the. Kita tukar. Saya ni terbalik ni, saya tak ubah ni. Okay. Ni kita guna yang ke bawah. Betul lah ni. Fail to reject hash, we reject hash null indicated that there is a significant mediating effect of mediator, which is social network on the relationship between X, which is task-oriented coping, and Y, which is philanthropic behavior. Okay, so we can say that social network partially, atau kita boleh interpret lah that the social network partially mediates the relationship between task-oriented coping and philanthropic behavior. So ini kalau fail to reject. Tapi ni saya tak tukar ni. Okay, so far so good. Boleh proceed lagi, sikit lagi. Okay, the second school of thought, mediation effect according to Preacher and Hayes.
Sorry, Doctor.
Yeah.
Sorry. Just tanya, in order to determine yang normal distribution tu, we need to determine each DV. I mean each variable tu
Each
kita determine
variable.
dengan normal distribution.
Yes,
only
each
DV?
variables, Mahfuz, from the very beginning. So kita assume when you are at this stage, you already done the screening, the screening and descriptive analysis. You all dah settle the outliers and so on. Okay. Okay. Next one is mediation effect according to Preacher and Hayes. Ini yang saya sebenarnya compare between Barron and Kenny and Preacher and Hayes. I prefer to use Preacher and Hayes lah. Dia lagi senang and lagi logik. Okay, so mediation based on Preacher and Hayes is equal to the indirect effect. So kalau if you refer to the earlier explanation on mediation analysis according to Barron and Kenny, they made the differentiation between full mediation and partial mediation, between full mediation, partial mediation and indirect effect. Kalau you all perasan tadi dalam table ni, mana dah? Table ni. Dia benda yang berbeza, full mediation, partial mediation, no mediation and indirect effect. But based on Preacher and Hayes, dia kata mediation is equal to indirect effect. Itu sama dengan indirect effect, regardless whether there is or not direct relationship between independent and dependent variable. So maksudnya Preacher and Hayes ni dia argue the logic of following the earlier 3 steps in Barron and Kenny, because to come up with the mediation model ni we already have the theory. Kita dah ada teori dah. For each path from IV to DV, from IV to mediator, mediator to DV, it's already been supported by theory. So maksudnya applicable kat sini, maksudnya when you want to propose the mediation model, make sure you have theory to support each path. Setiap path tu you all kena ada teori. Okay? Barulah you all boleh follow yang Preacher and Hayes ni. Okay? But dia kata tak perlu test pun. Dia kata kita boleh terus lompat ke step nombor 4. Okay, so mediation is said to be significant as long as it is proven that the indirect effect of independent variable on DV through mediator is significant. Itu sahaja. Maksudnya dia interested dengan path A dengan B sahaja. A, B. Tadi kita ada A, B, C prime and C. Tapi ni dia kata A dengan B je. Okay, results of the indirect effect test, which is the mediation effect. Faham Kalau dalam Pritchard and Hayes ni, I use the term indirect effect exchangeably with mediation effect. Sama. Okay, for criterion measure in the mediational analysis was based on the location of 0 in the confidence interval. To determine either the result is the result of indirect effect or mediation analysis, mediation effect is significant or not according to Pritchard and Hayes, we refer to the location of 0. Kita tengok kedudukan kosong. So when confidence interval does not include 0, which is 0 0 located outside, okay, value of indirect effect is considered to be significant. Macam yang 95 confidence interval yang kita baca dalam SLR tadi ataupun MLR. Okay. Okay, at 0.05 or 0.01 level for 95% and 99% interval. Okay, according to Pritchard and Hayes. Okay, boleh I thought I already uploaded the lecture note in Putra Plus. Rasa dah ada kan? Okay, please download the process macro for IBM Spss. Just follow the link given. Follow je. Sebab kalau kita nak pakai Pritchard and Hayes ni, we need to download. Tak tahu, rasa ada yang baru kot ni. Ada 4.1. Saya rasa saya dulu 3 lagi kot. I will share in our chat box. Session saya ni entah ada entah tidak, dah lama dah.
Mami,
Yeah.
notes yang dekat Putra Belas untuk mediation and moderation ni macam tak similar lah dengan apa yang Dr. Rumi present.
Ya ke? Saya baru, saya rasa saya baru upload tadi. Sama. Ya ke? Ke tu ada 3 je? Ada 3 slide je?
Itu yang PDF. Not yang PDF tu.
Yang PDF tu moderation. Itu belum lagi. Yang PDF tu nanti saya kena share lain. But because the file is too heavy, besar sangat, saya tak boleh masuk. So I have to convert to PDF only, then I can upload the notes there. Tapi moderation, but mediation, now mediation. Sama tak? Ke hanya 3 slide? Kalau 3 slide tu saya salah upload lah. Saya salah upload. Hold on saya share dekat group lah. Sebab dia ada lagi satu tu sebenarnya. Ni, okay, itu untuk mediation. Set moderation moderation ni nanti moderation. Aku tak lepas besar. Okay, ni okay. Okay, please download the extension tu dulu. Add-on, tambah dulu, download dulu add-on tu. So, saya nak tengok saya punya ada ke tak ni. Tak ada sini ni. Okay, tak apa. Kita buat sama-sama. Okay. Download dulu. Okay. Saya explain dulu Download, lepas tu letak tepi dulu. Sekejap lagi saya akan tunjuk macam mana kita nak install. Okay. For indirect effect, okay, to test mediation requires estimation of coefficient into regression equation. Okay, run a regression with the IV predicting the mediator. So IV dengan mediator, this will give us the alpha. IV, mediator sama macam dalam Barrett and Kenny. Then we need to run the second regression. Okay, run a regression with the IV and mediator predicting the DV. So IV and DV. IV mediator, IV DV. This will give estimate beta. Okay, note the IV is controlled in the equation. Okay, so the indirect effect of X on Y through M is quantified by the product of alpha and beta. Alpha multiplied by beta coefficients. Okay, so to test the indirect effect, we can examine the statistical significance of the indirect effect. Available statistical tests include process macro. Ini untuk kita test indirect effect. Dia ada process macro, which is we will use it after this. Okay, and then Sobel Z test. Okay, and then non-parametric bootstrapping. So this one also available in Ibm Spss, in Smart PLS, as well as in Amos. Okay. Ini sedikit introduction regarding bootstrapping. Okay, bootstrapping ni introduced by Bradley Efron 1979 as a general method for assessing the statistical accuracy of an estimator. It is a type of non-parametric in nature. Okay, and then in which in the analysis of bootstrapping ni, okay, the system will automatically resample your data ni with replacement. Dia akan buat dalam analisis tu. Okay. Okay, ni full or partial mediation sama macam dalam Barrett and Kenny. Okay, we have two options. We have three options, either full mediation, partial mediation, or no mediation. Okay, we refer the result we refer to indirect effect and direct effect. Okay, A, B, C prime. Ini saja yang kita nak. Path A, B and C prime. Okay. Okay, next one, effect size. Hak ni sebenarnya we can use both in Barrett and Kenny and Pritchard and Hayes. Sebenarnya last time dia hanya dipropose oleh Barrett and Kenny, Pritchard and Hayes. Tapi recently I see there are a few practitioner that apply the Barrett and Kenny school of thought also report effect size in their mediation analysis. Okay, so the effect size in mediation analysis we measure through K square or kappa square. Okay, kappa square suggested by Pritchard and Kelly, 2011. So kappa square can be interpreted in the same light as the coefficient of determination, which is R squared, with the guidelines of Coherence 1988, where small, medium, and large effect size are stated as 0.01, 0.09 and 0.25 respectively. So kita guna indicator by Coherence. Ini dia punya cut off point. Nanti saya tunjuk macam mana. Okay, so kappa squared were calculated based on the values of variance of independent variables, variance of independent variables, mediator, dependent variable, covariance of x toward y, x toward m, and my. Okay, beta of x on m, which is path A, beta of x on y, which is path B, in measurement model as in, nanti kita pakai this website ni. Okay, panjang sikit ni, tapi dia senang. Okay, saya dulu pakai ni, versi ni. So sekarang 4.1 saya tak tukar lagi. The latest version is version 4.1. Okay. So download the process version 4.1. Jadi, okay. So first select file location to save the file. Open zip file. Extract file process ni. Extract dulu. Okay. Opening and executing the process macro definition file. and follow the instruction given. Okay, saya nak buat pula. Sebab step ni saya selalu lupa, that's why saya kena buat betul-betul macam tu. Okay, stop sharing. This is the zip file. This one extract file. Okay. Okay. Dah ke? You all dah ke?
Dia akan keluar kat syntax editor, Doktor.
Okay, sekejap. Saya selalu terlupa untuk step install ni. Sekejap Okay, yang ni you all klik extension, klik utilities and klik install custom dialog. Okay, klik extension, utilities, install custom dialog. Tapi kalau tadi dia suruh, sekejap hold on file. Ini dia punya, actually this is the instruction. This one ni. File, klik file, open syntax. Klik file, open syntax. Choose the process.sps ni and then click open. Itu saja. Sekejap saya buat. Okay, file, open, syntax. Okay, so choose process.sps and then click open. So kalau kat sini, dah ke? Click open. Kena highlight ni, sekejap Open.
Ada window syntax editor.
Okay, tapi kena run dulu tak? Run. You need to run first, right? Okay, klik run ni. Klik. Select all. Klik run. Dah. Dah. Done? Process is now ready for use. Done? Boleh? You boleh tak? You want me to repeat the step?
Repeat, Doctor.
Okay, good. Okay, boleh. Okay, first, can you see my screen? The SPSS file? Nampak tak? Okay, what you need to do is click file, click open. Click file, click open. But make sure you extract the process file into your computer. From the zip file tadi, you extract into and make one folder for process 4.1 tadi. Okay, so for example, I already located mine in my download download document. Contoh saya letak kat sini. Kalau saya letak dekat ni. Ni dekat download ni. Bahagian download ni I have this one. Okay, so I have this folder here. Okay, so now go to our SPSS file. Okay, go to our SPSS file, click file, click open, and then click syntax. Open, choose syntax. Okay, file, open, and syntax. Okay. Okay, and then after the open syntax box appear, you choose process, you choose this one, process.sps. Make sure it directed you to that file lah. So for example, I use download just now. Ni process. So I have this one. Okay, so choose process.sps. Okay, and then click open. Click open. Okay, so now it will direct you to this syntax window. Nampak? Syntax window. Okay, for syntax window ni, you select all. Control Alt. Control A. Select all. Okay, and then you click this green arrow. Ni. Run selection. Run selection until dia keluar that notification indicated that your apa tu, until you get this one, this notification. This one. Until you get this notification. Process is now ready for use. Dapat?
Dapat, Doktor.
Okay. Dah. Kelima dah. Okay. Dan sekejap ni. Ini saya punya data ni. File. Tapi but still if you go to your data set or software, you still cannot see the option installed in your option here. Tak ada lagi kan? Ni sebenarnya barulah follow this step. Dia first time je susah, lepas tu senang lah. Only then we follow this step. Ni. To add custom dialog process. Okay, first click extension. Okay, you're on your option kat computer tu. Click option, click extension, click utilities and install custom dialog. Okay, extension, utilities, install custom dialog. Done? Done Okay, next one. Okay, under the process ni you choose your process folder, process 4.1. And then click open. Okay, process version 3 for SPSS tadi, click open. And then click and choose custom dialog builder file. Ada? Ni saya tak tengok lagi saya punya. Ada? Custom dialog builder file. Click open. Okay, and then choose process.spd. Click open and then click OK. Done? Now, in your regression option, you can see there is one new option added. Cuba saya punya pula. Boleh saya reinstall ni. Extension, custom dialog. Extension, hold on. Extension, custom utilities, install custom dialog. Okay, this one, process.spd, open. Okay. Okay. So then to check either it is successfully installed or not, you can check on Analyze, Regression, then you can see this one this one. Tapi saya punya 3.5 lagi. Apalah, sama je, lebih kurang je rasanya. Okay, process version 3.5, mine still 3.5, maybe after I restart dia akan tukar lah kot pada 4.1. Tapi ada Semua ada?
Yes.
Okay.
Ada doktor.
Okay, now kita pergi balik kat slide. Mana slide saya? Okay, ni. So done this part. Okay, it's already there. Okay, now we are ready to run our analysis. Okay, to run the first analysis, click Analyze, Regression, and choose Process version 4.1 by Andrew F. Hayes. Okay, Analyze, Regression, and then tick Process. Analyze, Regression, Process. Okay, so now under the process box, you choose PB as your DV, as Y. Okay, task oriented copying as X variable under X variable, and mediator social network mean. Okay, ini sikit lagi ni. Okay, for model number ni, saya tak explain lagi model number ni. Okay, it's okay. For model number, now choose 4. Model number 4. Okay, confidence interval set at 95. Number of bootstrap sample use 10,000. Okay, and then tick for bootstrap inference for model coefficient. Dan model ni nanti saya explain apa maksud nombor 4 tu. Okay, and then choose option. Tick option. Under option, you tick for show total effect model. Okay, effect size, heteroscedasticity, none, decimal places 4, probe interaction if P lesser than 0.1, then click continue. Okay, and then click OK. Okay, ni saya terangkan berkenaan model. Okay, so actually when Preacher and Hayes proposed the process system ni, he come up with the book. So the book ni, the name of the book is this one, Introduction to Mediation, Moderation and Conditional Process Analysis. The second version, which is 2018, I thought dia ada lagi the latest lah. I can share with you the book, the soft copy of the book if you are interested lah. So in the book, okay, Preacher and Hayes specify the number of model ni. Okay, so number 4 ni, model number 4 ni reflecting the simple mediation model. Sebab itu dia letak number 4. Number 4 ni reflect the simple mediation model. Model number 1 reflect the moderation model. Ini contoh moderation. Saya tak ajar lagi ni, tapi saya tunjuk. Model 1, later on when we want to run the moderation analysis, we need to choose model number 1. But for simple mediation analysis, we choose model number 4. Okay, nombor 4. Faham kenapa dia nombor 4? Okay, so this is the output. Okay, so this is first. Do we share similar output? Oh, saya punya sample size 300. Sorry, you all punya 60. Saya rasa result nanti akan beza sikit. Okay, tak apa. Okay, so this is we use the model number 4. Okay, simple mediation model. Okay, our IV, DV and mediator. Okay, and then the sample size. Yours is 60, right? 60 sebenarnya tak cukup, tapi tak apalah. Okay, so this is the model yang kita nak. First, model summary dia R. R indicate similar to Pearson product moment correlation result ataupun dalam multiple correlation coefficient. Okay, R equals to 0.446, R squared 0.1989. Explain the percentage of variance in mediator. Explained by X by IV. Okay, Second one, next one, the significant. Okay, the significant value F and significant F. Okay, next one. Okay, in the model, yang ni outcome model outcome model is mediator. Okay, kita tengok outcome variable ni mediator. Maksudnya hubungan antara IV and mediator. Okay, yang ni outcome variable ni kita tengok ni model ni dulu. Okay. So this one is the coefficient table. Kalau in simple linear regression, this one reflecting the coefficient table. So we have constant and then we have IV. Okay, so in this line, in this row, we can see the influence of X on mediator. The influence of IV towards the mediator, which is A path A. Okay. So kita recall balik path kita. So IV mediator. Okay, so what we need to report is the coefficient. This coefficient, unstandardized coefficient. So A now equals to 0.4474. 0.4474. Ni kita punya A. Unstandardized beta for path A. Okay, clear And then the result also significant. The result also significant. Okay. Next one. We can also indicate the the result ni according to the location of zero. Kalau zero located outside the range, the result is significant. Zero located within the range, the result is not significant. Sama So next one. Now the outcome variable is PB, philanthropic behavior. Okay, first we look at the correlation coefficient. Okay, but this one reflecting the multiple correlation coefficient. Okay, and then R squared, okay, 0.3209, explain the percentage of variance in Y explained by IV and the mediator, and then the result also significant. Okay, to see the individual contribution, sebenarnya we are only interested at path C prime. Okay, ini C prime, TOC towards DV, path C prime. Okay, so we can see, we can see our unstandardized beta equals to 0.1893, the result significant, and then zero located outside the range of lower bound and upper bound. Okay, next one, path B. Okay, so the unstandardized beta equals to 0.5003. Okay, the result is significant, and then zero located outside the range of lower bound and upper bound. Okay. Okay. Settle ni. Next one, the outcome variable PB mean, but this one for total effect model. Total effect. Okay. This one we are interested in C. Ni. Task-oriented copying, the influence on PB. Okay, so the unstandardized beta equals to the C ni, beta equals to 0.4131, significant value equals to 0.000, significant, and then zero located outside the range of lower bound and upper bound. Settle. Okay. So ini dia. So this is the total direct and indirect effect. So total effect of X on Y. So we can see the path C equals to 0.4131. Direct effect of X on Y, effect beta equals to 0.1893, and indirect effect 0.2238, which is effect path indirect effect A times B, A multiplied by B. Okay. And then this is the location of zero. So what we are interested with is actually this one je. Sebenarnya kita nak this one je ni. Ni, banyak-banyak tadi ni je yang kita nak. Okay. This is, we reflect the indirect effect, we also reflect the mediation effect. Ni je. Okay. Yeah. Okay, next one. Tak ada apa dah. Okay, so again, how to determine the relationship, the influence or the mediation effect, it is based on the location of zero within lower bound and upper bound range. So this one, ni. Lower bound and upper bound, ni, this one. Either the result, the AB effect ni significant or not, it is based on the location of zero between these two range. Okay, so zero now located outside the range. So the result of mediation or indirect effect ni significant. Faham Am I too fast? Bagi tahu saya kalau saya telah laju Okay. Okay, so ni kita punya possibility. So since the case tadi the zero located outside the range, so we reject the hash knot. It is indicate a significant indirect effect of IV on DV through mediator. Ini kita punya finding lah Okay, so this is the finding. We reject hash knot. There is a significant indirect effect of task-oriented copying on philanthropic behavior through social network. Okay, so ini kita punya conclusion tadi. Okay, so there is a significant mediating effect of mediator, which is social network, on the relationship between X, which is task-oriented copying, and Y, philanthropic behavior. So we can conclude that social network partially mediates the relationship between task-oriented copying and philanthropic behavior. Okay, any questions so far? Ada soalan? Benda baru dia lambat sikit lah. Yang tadi tu laju sebabnya benda dah lama. Any question? Senyap semua tu.
Digest.
Okay, tak apa. Digest. Okay, so now after we already got the finding, the output for mediation, we already determined our mediation. Now we want to determine how much is the effect of our mediator in the model. Okay, so we can determine the effect size by using kappa squared. Okay, so these are the values that needed in our to run the to calculate the effect size. Okay, so we use the kappa squared. So these are the 8 values needed: variance of X, variance of M, variance of Y, covariance of X. Kita run balik. To get the variance of X, variance of M, and variance of Y, we need to run the descriptive analysis. We recall again the descriptive analysis that we did in last few weeks. Okay, we click analyze, click descriptive statistic, and click descriptive. Analyze, descriptive statistics, descriptive. Next. Okay, you locate the 3 variables: social network, philanthropic behavior, and task-oriented copying under the variable box, and then click option. Click option. You tick for variance. Tick for variance. Okay, and then click continue. And then click OK. So we got the variance for all the 3 variables. Okay, variance, social network 0.251, philanthropic behavior 0.29, task-oriented copying 0.25. Done? Okay, next one, we want to calculate the covariance. Okay, to calculate the covariance of X on Y. Okay, we click analyze, regression, and choose linear. Analyze, regression, and choose linear. Okay, we locate ada DV as PB mean and IV as TOC mean, and then click statistic. We click the covariance metric. Click the covariance metric, then click continue, and then click OK. So we have the covariance for X on Y, which is 0.003322. Okay, next one, covariance of X on M. We repeat the same step. We just need to change the DV. We click analyze, click regression, click linear. Okay, for the DV, we change from PB mean to social network mean. social network mean. All the criteria remain. We just pick for covariance and then click continue, and then click OK. So this is the output for covariance, which is equals to 0.002705. Okay. Next, the covariance of M on Y, the mediator on DV. Okay, we click analyze regression linear, analyze regression linear. In linear regression box, we put again our DV as PB mean and our IV as social network. Okay, the rest we remain. Okay, we want to look for the covariance and then click continue. Then click OK, and then our covariance is 0.002725. Okay, sama. Next, beta of X on M, which is path A, and beta of M on Y, on B. So in which we can get from our earlier output daripada mediation analysis. So beta of X on M, which is path A, equals to 0.4474. Beta of M on Y, which is path B, equals to 0.5003. So kita dah ada ke semua values. Now we have already obtained all the values. We are ready to plug in the values into the respective box accordingly. Okay. So we go to the website. This website. Hold on. Saya copy nanti saya paste. I paste at our chat box. Okay, go to this website. Okay, you just plug in all the values into the box accordingly, according to the according to the element. Include je. Okay, dah. Masukkan value. Variance of X 0.25, variance of M 0.251, variance of Y 0.29, covariance of XY 0.003322, covariance of X on M 0.002705, covariance of MY 0.002725, beta of X on M, path A 0.4474, path B 0.5003. Done? Yang lain tu undefined dah tu.
Sorry, teacher. This web.
Done? Oh, was not found on this server. Memang tak boleh buka
Yes, we cannot open this page.
Is it everybody cannot open the page?
Tak dapat, Doktor.
Oh ya ke?
Ya, Doktor, tak dapat.
Batuk semua senyap tu. Dah tutup agaknya website ni. Memang tak apalah. Okay, nanti saya akan tengok balik this one lah. I will update you with the recent the updated link. Nanti saya tengok balik Tak apa. Saya pun tak check tadi. Okay, but if you plug in the values, okay, into the equation, so you will get the kappa squared equals to 0.208, which is according to the coherent effect size, it is referring to the medium effect size. Okay, it is referring to the medium effect size. Last year okay lagi. Saya tak check ni. Okay. So done. Any questions so far? Yang ni je, nanti saya update balik website. Ada soalan tak?
Doktor, mediation masuk exam ke doktor?
Ada.
Mediation dengan apa satu lagi? Moderator.
Mediation and moderation. Ada.
Oh, assignment je yang tak ada.
Nanti saya tengok balik. Saya lupa. Rasa macam ada. Kalau ada pun sikit je lah. Sikit je. Okay. Lagi soalan? Ada dah? Okay, so if there is no more question, make sure you mark your attendance through Putra Blast. Make sure you mark your attendance through Putra Blast. So we stop here for today. Again, I would like to remind everybody, next week we are not going to have any class. Okay, we will meet each other in the next 2 weeks. Okay, next 2 weeks. Next week tak ada kelas. Okay?
Okay, doktor.
Okay.
Okay, so thank you so much guys. Take care. Assalamualaikum.
Selamat pagi.
Salam.
Bye-bye.
Thank you, doktor.
Thank you.